For this video, we are going to talk about the section 7.2 on the one sample proportion test. There we go. I paused recording so I could open up my calculator. I didn't have it open before. And now we can get started. So to test a population proportion, there are a few things that we need to define first. Usually Greek letters are used for parameters and Latin letters are used for statistics. When we're talking about proportions, it makes sense to use P for proportion. The Greek letter for P, though, is pi. So that's a little bit confusing because we usually associate that with a certain number. There is a Greek letter that looks a lot like P, the Greek letter rho, but the Greek letter rho is actually like an R. And it also looks kind of incredibly similar to a P, and would also be hard to distinguish. So instead, we use P for the population. It's best to use P for the population proportion here. So a different symbol is needed for the sample proportion. The convention for this is to use a P with a hat over it. We call this P hat. This way we know that P is the population proportion and P hat is the sample proportion that's related to it. So when we're conducting a hypothesis test for a one population proportion, a lot of the steps for these tests are very similar. So first step is state the random variable and parameter in words. In this case, X is the number of successes and P is the proportion of successes. Step 2 is to state the null and alternative hypotheses and the level of significance. Remember, we have to state the level of significance before we collect our data. So the null hypothesis is going to be that H naught is P equals P naught, where P naught is the hypothetical proportion, the assumed proportion. And the alternative hypothesis is that P is less than P naught, or that P is greater than P naught, or that P is not equal to P naught. And we want to choose an alpha that is appropriate for the problem. Step 3 is stating and checking the assumptions for a hypothesis test. Step 4 is finding the sample statistic, the test statistic, and the p-value. Here, p hat is x divided by n. That's the number of successes divided by the number of trials. And the test statistic, z, is p hat minus p naught divided by the square root of p times q all over n. The p-value is the left tail, right tail, or sum of both tails. Technology will usually calculate the p-value for you if you tell it the alternate hypothesis, and we'll see that shortly. The conclusion is if the p-value is less than our alpha, we reject the null hypothesis in favor of the alternate hypothesis. Otherwise, we fail to reject the null hypothesis. And the interpretation is where you interpret in real-world terms the conclusion to the test. The conclusion for a hypothesis test is that you either have enough evidence to show that the alternative hypothesis is true, or you do not have enough evidence to show that the alternative hypothesis is true. Our first example here is that a concern was raised in Australia that the percentage of deaths of Aboriginal prisoners was higher than the percent of deaths of non-Aboriginal prisoners, which is 0.27%. A sample of 6 years of data was collected, and it was found that out of 14,495 Aboriginal prisoners, 51 died. Do the data provide enough evidence to show that the proportion of deaths of Aboriginal prisoners is more than 0.27%? So first, we want to state our random variable and our parameter in words. So X is the number of Aboriginal prisoners who died, and P is the proportion of Aboriginal prisoners who died. Step 2 is to state the null and alternative hypotheses in words, just to state the null and alternative hypotheses and the level of significance. Here, our null hypothesis is that P is equal to 0.0027, and our alternative hypothesis is that P is greater than 0.0027. And for a more thorough discussion on determining this level of significance, look at example 7.1.5b in the textbook. There's a discussion of this example in particular in determining the level of significance here. Then we want to state and check the assumptions for the hypothesis test, and find the sample statistic, test statistic, and p-value. Here x is 51, n is 14,495, p hat is x over n, and so when we do 51 over 14,495, we get about 0.003518. Our test statistic, z, is p hat minus p divided by p times q all over n. So we get about 1.8979 when we plug everything in. To determine our p-value, here we're finding the probability that z is greater than 1.8979. This is because our alternative hypothesis is that p is greater than this 0.0027. And to find this means that our lower bound in our normal CDF should be 1.8979. Our upper bound should be 1e99. Here our mean is 0 and our standard deviation is 1 because the z values are normally distributed with a mean of 0 and a standard deviation of 1. And this gets us about 0.029 for our p-value. Our conclusion here is that since the p-value is less than 0.05, we reject h0. This is because our chosen alpha value was 0.05. The interpretation here is that there is enough evidence to show that the proportion of deaths of Aboriginal prisoners is more than the proportion of deaths of non-Aboriginal prisoners. Looking at another example, this is an example with technology. A researcher who is studying the effects of income levels on breastfeeding of infants hypothesizes that countries where the income level is lower have a higher rate of infant breastfeeding than higher income countries. It's known that in Germany, considered a high income country by the World Bank, 22% of all babies are breastfed. In Tajikistan, considered a low-income country by the World Bank, researchers found that in a random sample of 500 new mothers, that 125 were breastfeeding their infant. At the 5% level of significance, does this show that low-income countries have a higher incidence of breastfeeding? In our calculators, what we want to do is we want to hit stat and go right twice to tests and choose one prop z test. One prop z test. Then we type in p0, which is 0.22. X was 125. N was 500. And we were given a percent level of significance. Notice there's actually nowhere to type this in, but we'll keep that in mind. We do want to correctly choose the alternative hypothesis here. We wanted to determine if low-income countries have a higher incidence of breastfeeding. So we want to determine if P is greater than P naught. And we hit calculate. And here we get a p-value, where it says p equals, we get a p-value of 0.05268. So our conclusion here is that since our p-value is more than our alpha value, our alpha was 0.05, we fail to reject the null hypothesis. The interpretation here is that there is not enough evidence to show that the proportion of women who breastfeed in low-income countries is more than in high-income countries.